Okay, the last class we saw how to send arguments, parameters, and along with that we saw life and scope of variables also. So one method keeps on calling other methods, and from one scope you'll send the values to another scope. Okay, so always say value is available in only one scope. That value is stored in a variable, and it will be available only in one scope. If you want to work with the value, you have to use the variable. If you want to work with the value, you have to use the variable, and that will be available in a single scope. If you want that value in another scope, that is, I'm talking about method now, you have to send it as argument. From caller to call, you'll send it as argument. Same way, if you want to give value from callee method to caller method, you'll use return type. Yesterday I showed you how to call, how main will call M1, M1 will call M2, M2 will call M3, like that. It was a chain. You don't have to worry too much about the chain. Just if you understand how one method will call another method and how one method will return the value to another method, that chain you can handle, it's not a problem. But work on two methods. One caller, one callee work extensively. Other methods will become easy to you. Okay, just one caller, like one caller is there, M1. M1 is the caller, M2 is the callee. Or main can be the caller, M1 can be the callee, anything. So you learn only two methods first. How to send from here to here, this scope to this scope, how to give from this scope to this scope. Once you are comfortable with these two, from here you can send here, from here you can send here, from here you can send there. That is how it will happen. Clear? So again from here you can send to what? M3. I am not writing the signature. Signature will depend on how many values you have to send. Same way return type will depend on what you want to return. So work with two methods first, extensively work, then automatically you'll understand how to send the values to more methods. It's a chain like this. Clear with this? And after this I started off with oops. Are you clear with life and scope of variables? Life and scope. It's a very very important subject, but I discussed only about life and scope of local variables. There are two more variables which you have to discuss. So in Java there are three types of variables: instance variables, static variables, and local variables. We discussed only local. Gradually we'll cover all that, then you'll understand. Clear? So yesterday's topic is clear for you now? Okay. So next we'll start moving into oops now. Okay, or we'll get into user-defined data types. Yesterday I gave you an intro, okay, about what is a user-defined data type. I gave the introduction to what it is. I did not speak from any language perspective point of view. It was very generally I discussed what is a user-defined data type and why it is provided by languages. Okay, so language will give you primitive data type to store value, no doubt about it. Okay, similarly user-defined data types are used for the same reason. So why do you use data types? Simple, one reason. One reason why you use a data type is to store value. That's it. Okay, let it be primitive or let it be user defined. The only reason why we are going to use it is to store values. But in primitive variables or in primitive data types you can store a single value. But in user defined data types you can store multiple values. Okay, but it is heterogeneous. Okay, it's heterogeneous. So see this, all the data types provided by any language. So language has to give you the data type. There is no excuse. If the language doesn't give the data type, there is no question of learning the language for programming. There is no question of learning it for programming. Okay, so it has to provide. And the three types of data types are primitive types, derived types, and user defined types. These primitive types are also known as predefined. They are also known as predefined. Predefined data types means it is defined by the language only to you. Predefined. Primitive data types are also known as predefined data because it's given to you by the language. Then derived, then user defined. These are the three types of data types, and all these data types are used for storing value. But the difference is this will be used to store single value. Again, type of value will vary: int, float, int value, or sorry, what is that? Decimal value or fractional value or character value or boolean value. Depending on the type of value, you'll use the variable. So derived values are used for storing what? Derived data types, multiple values, but they'll be homogeneous, same type. User defined data types are also used for storing what? Multiple values, but it is of heterogeneous, means combination of different data type. And yesterday I gave you the idea also why we use different data types. What is heterogeneous? I explained you from the UI point of view, because This is your application, and the values from your application will enter from database also, from tables. There will be tables like this. You will be having like this. Like if you take a student table, example, yesterday I took employee, today I'll take student, anything you can take. Student ID, student name, this is database, you don't worry what it is. Marks 1, marks 2, means some subject marks. So like this you can have some marks, then you can have total, then you can have average. Like this values will be there. So these are how values will be stored. Student ID is 101, his name is so and so, marks he has got is 65, then he has got 70, then total 65, 75 take. Total will become what? 140, average is 70. Like this values will be there. Okay, or sometimes you might be receiving the values from UI also. Like you might be having student ID. See, this is how the applications are developed. His name, his marks 1, his marks 2, like this values will be coming now. Total, okay, average, like this all so many values will come now. So when you are getting so many types of values, okay, so this is user interface, that is database. Okay, those who don't know database, don't worry, it's one kind of secondary memory. Okay, so we'll be seeing database in depth later. So but this is how an application is written. You can develop this kind of an application using any language, C, C++, Java, that is irrespective now. Okay, but values will enter your application. So the language should be so comfortable for the developer that he should be able to handle all these type of values. Okay, so we learn that language or we choose that language. So if you start to choose the language now, you can see Java becomes the easiest. We want to develop an application for developing what? This kind of an application. So C, C++ and all are very difficult for doing this, but Java is very easy. Why? The question is that. So because of its rich features. You know what are the rich features of Java? The character set, the 9 things what we studied. Okay, the character set, literals, variables and all that. Main thing among that is data types. So when you're getting so many values, so you'll be having more values like this, 101, 102, more students will be there. He can have max like 50 and 60, total will be 110, average is 55, then he might have something like 45 and 55, total will be 100 and average is 50, like this values will be there. So either they'll come from here or they'll become from here. But once you get the value, so you're getting multiple values related to one single entity now. Okay, I could have used what? Say I can use variables like this, int id, string name, int marks 1, int marks 2, double total, double average. I can use variables like this. So when I get the values, I can store it in these variables. But when I start getting multiple students now, okay, what will happen now? Again, you have to go for more variable names, more variable names. So that is when you start finding it very difficult to maintain now and manage, because whose marks belongs to whom, whose total belongs to whom, you will be unable to identify. That's why we start grouping now. Okay, we start using user-defined data. Okay, if you use C, you will create on structure. If you use C++, you will create on class. Similarly, in Java, we have one support to create a user-defined data type called as class. So all languages will are trying to give the same kind of support. Okay, but the difference is which data type is more powerful. At the same time, it should be user-friendly now. So we want a very powerful data type now. At the same time, it should be user-friendly. See, the more powerful the data type becomes, what happens? It's complicated for the developers to learn and use. It is powerful, means you should learn the power of it now. So to learn also we want comfortability. At the same time, it means it should be very powerful. At the same time, it should be user friendly now. So instead of storing it in single values like this, what we start doing, we start depending on user defined types. Now a primitive multiple values, but this user defined data type is again nothing but what? Collection of primitive plus derived. It's a collection of these two. Understood? So if you are having multiple values, now see, if I am having multiple phone numbers, I can have an array of what? Phone. I can have multiple buttons here. See, that time I can go for array of phone. So phone 1, phone 2. You can use an array now. So now see, when you're getting so many kinds of values, how you store the values and how you organize it, that is your wish. Can use an array like this. Okay, so this is where it becomes very important now. Okay, you should know how to design your user-defined data, and for this immense experience is required. It is not that you'll understand it in one day now. Okay, because for this you have to understand what is database, what is UI, user interface. Depending on that, the user-defined data type will be designed now. So it takes a lot of time. Okay, it takes a lot of time. Okay, so but slowly, gradually you'll start understanding it. And in all languages you have to study this. But Java is more easy as compared to other languages. That thing first you keep in mind. Okay, because initially when you are learning something, you'll get some hurdles and you'll start blaming the language. In fact, this is easy in Java as compared to other languages. Now, can you do the same thing in assembly language or binary language? Imagine how difficult it is. At least think now, Java is 1000 times better as compared to those languages because it's a high level language. 1000 times better. If you compare to C, it is 100 times better, but if you compare to other languages, it is 1000 times better, where it is, there's no question of learning only, and that language also will not give the support also. So like that, problems will start off. So understanding what are user-defined data types, so a language which gives you these many data types only is successful. Okay, you might be thinking there is one headache in C, they are giving you structured data type, it's very complicated, but if they had not given it, C wouldn't have been so powerful. So it is required. In C it is required for it to become powerful. It is mandatory. Okay, it is mandatory. But the problem is, it is difficult to for the developers to learn and use. They are giving it, but it's difficult for the developers to learn and use it. Okay, so that's the reason. Let's start seeing it in C now. In Java, how it is done. In C, what happens is you'll write something like this: struct student. This becomes your user-defined type. That's it. That's it. It becomes struct student. In Java, one small change. Instead of struct, what we say? Class. That's all. So end of the day, we are saying all languages are giving the support for what? Defining user-defined data types. They are giving you a mechanism to design user-defined data types. That's it. Are you clear with this concept now? Basic? Because now today we'll be designing user-defined data types and we'll work with this. So what we do, first we have to define it. In all languages, this is the common process. You take any language, C, C++, because why I compare Java with C and C++ is, one is it's following those syntax. Second reason is you know those languages. If I tell you something on C, you will understand it. But if I talk something on Pascal, will you understand? You will not understand. So the reason why I compare is because one is it's following that syntax. Apart from that, you know those two languages. To compare it will be little easy for you. Okay, so in all languages you define the data type. Yes or no? Next, what do you do after defining it? You allocate memory for it. After allocating the memory, what do you do? You will store the address of that memory into one variable. Common process, generally I am telling now. Very common process. You define a data type, you allocate memory for it. Yes? And then the address of that memory will be stored in one variable. That can be called as a pointer variable or reference variable. Story is different. Concept is same now. Understood? If you are not followed, we will be seeing it with programs only. Concept is this. So we are learning concepts rather than what? Output. Okay, so all languages talk about, you define it, you allocate memory, the address of that memory you store it in one variable. One language calls that variable in one style. C calls it as pointer variable, C++ also pointer variable, but Java calls it as reference variable. The terminology will vary, but at the end of the day the concept remains same. There is no difference about that. Are you clear? So this is one idea. So I will be concentrating more on user-defined data types. Okay, user-defined, sorry, what is that? User-defined data types. Yeah, user-defined types or user-defined data types, all the same. Okay, so we'll be concentrating on this now. Yeah, and here in Java there are 4. So obviously it will take some time now. Obviously it will take some time. And once this is complete, Java is over. One more topic will come up, except landing. With that, language ends. Okay, and after that, if you want to do anything, input output, you might be thinking multi-threading and all that. That is part of language, but it is that support is given to you by library. That support is given to you by library. Java finishes with this much. So Java language is very simple, compact and precise. They know exactly what they want to do. It's not a very complicated language. Okay, so it's very easy to learn. After that, we go on to study only libraries. There is no logic you'll write. Clear this? So shall I start off now? Okay, again, to be little more to give you little more information, in Java when you want to learn Java, two things you have to learn. One is the language syntax, means Java language syntax. Second one is OOPS you have to learn in Java. That's it. Two things you have to learn. Now these two things have been derived from what? This has been derived from C. This has been derived from C++. This we already completed. Yes or no? It's already over. But the syntax in C was, means if you go on to learn the syntax in C, minimum how many days you take? Just see, you just go, the same what you learnt in Java now you go and learn syntax in C, it is very comfortable. Understood? You didn't know the proper syntax of C, that's why I went to give you some information on C syntax so that you'll be comfortable in programming Java. But after learning Java syntax, you can still go and learn what? C syntax. Okay, but in fact Java syntax is more better than C, no? Like if you see type checking, compatibility, some compile time errors, okay, all that, you'll start seeing more. So Java syntax is 1000 times better than C syntax. That also you'll see. So it's refined. Syntax wise, if you see, it is following C syntax, but at the same time it is more refined. Okay, there are no junk values, many things, many advantages are there. Okay, and if you try to use an unused variable, in Java you get error, but in C what happens? It will compile. I'll declare one variable in Java. In main you declare one variable. You say int a, SOPA you print. What did you print? Error, no? Variable might not have been initialized. These are all syntax problems. Okay, C will allow you to compile. Type checking you take, then garbage values you take, then using uninitialized variables you take, and whatever you see. Java syntax is 1000 times better than C syntax. It is refined. Whatever the problems were there in the syntax of C has been refined in Java. More and more you'll understand because you are not coded much. So I can't talk more on syntax, but you'll be seeing it very clearly. Similarly, we have to learn OOPS. So now OOPS is a very generic subject. I told you there are so many types of programming paradigms which came into existence. So there are so many things came. Among them, OOPS became popular. But Java was not the inventor of OOPS. Some scientists invented this programming methodology. It was tried to be implemented by many languages like Ada, Smalltalk, Eiffel, so many came up. They tried to give OOPS, but they are not successful. What reason? Not user friendly, and they didn't have best implementation of OOPS. The syntax was complicated. First reason. Okay, see now developers were addicted to coding C. Suddenly a new language comes with good features. Yes, I do agree, it will come. It is having brilliant features. But who will learn the new syntax? Problem. So those languages had their own syntax and all that. So that was the problem. So one of the language at the same time which became popular in spite of improper OOPS was C++. Reason is it was following C syntax. It was following it. But it was still successful. You can't help. See, I want to do something, but there are limited options. Even though it is bad, we choose the best among them. Understood? We choose the best among them because there are limited options for you now. When there are so many limited options, the only option is what? Among the worst, choose the best. More than that you can't do anything. Somehow C++ became popular. C++ what it was doing was it was having OOPS, but it was improper, but it was following C syntax. That is why many developers from C they started moving into C++. They were comfortable. So again, it was not a good language. Main drawback of C++ was many drawbacks are there, leave it. But by that time, portability was becoming a big issue. What code is written once should be executed in any platform, any hardware. Portability was becoming a big issue that time because of internet and all that. Okay, we'll talk about that history also in detail later. But portability was becoming a big issue. Along with that, a new language was also needed. So a new language was getting designed. So these people kept these things in mind. They wanted to have a very comfortable, user-friendly syntax. Means it should be user-friendly. It should be portable. It should have OOPS, best implementation of OOPS, and they designed it. And that is Oak, later on named to Java. I told you about this history. Let's not get into the history, just I'm introducing you OOPS now. Okay, my intention is to introduce OOPS. So now OOPS can be learnt in any language. It's not that you have to learn OOPS in C++ and come and learn in Java. Before I start off OOPS, I'm just giving you this clear idea because you are sitting with wrong assumptions that what? To learn Java, what is required? C++. It is a totally wrong assumption. It is only a myth created in the market. It is not required because in C++ most of the OOPS implementation is bad. Okay, most of the OOPS implementation is bad, but at the same time Java is having the best implementation. So you learn wrong things and come here, and then you try to learn good things. You are unnecessarily wasting time in C++ now. The same time you put here, you can learn it more better. Okay, so I'm just clarifying what is OOPS and what is why it is not necessary to learn C++ to learn Java. It is not necessary. Okay, so in C++ also, if you go to learn, actually you will not be learning syntax there, you will be learning OOPS there. Nothing else. What are OOPS means, what is encapsulation, what is inheritance, you go on to learn that there. The same OOPS you can learn directly in Java only, because there it is not implemented properly, you can learn it here. So Java is a fully refined language. Even in OOPS, it has got the best implementation of OOPS. So syntax wise also it is refined, OOPS wise also it is refined. It is having the best implementation. So Java is combination of these two. Okay, are you clear with this? Java is a combination of these two, but it's a different language, plus at the same time it is portable. So it's having refined syntax plus refined OOPS. Understood now? Java is having refined syntax as well as refined OOPS. Both is refined here. Clear this? Refined. Okay, so one side we have to learn OOPS also, other side we have to learn data types also. Two things going parallelly now. Okay, to implement OOPS now, Java says you can use these user-defined data types. So Java's user-defined data types are so rich that they are able to store values also, plus they have the capacity to implement OOPS also. So when you are studying user-defined data type in Java, you have to learn two things. One is how to store data. At the same time, how to implement OOPS using the data. Two things you have to learn. So Java's data types are very, very powerful. Very powerful. And at the same time, it is very comfortable to work with that also. It's very comfortable to work with that. Okay. So, and in Java now, to implement OOPS, which are the four data types? Class. I keep repeating this always. Abstract class, subclass, and fourth one is interface. So Java is giving you four data types to implement OOPS. Understood? User-defined data types. So you can implement OOPS using that also, plus you can store data also. But the question is now, why did Java give 4? Yes or no? So you will understand now. Why, means in which scenario we use class, in which scenario we use subclass. Depending on scenario we choose the data type. Like even in C you got structure, enum, union and all that. In one scenario one are suitable. You cannot use everything everywhere. So that's why they give so many data types. Clear? So we'll be getting into user-defined data types of which one now? Java. Okay, so it takes time. Initially I'll not be covering OOPS in that user-defined data type. I'll be only concentrating on what? How to store values in the user-defined data type. Understood? You understanding now why user-defined data types are used now? If generally when you are having multiple values belonging to one entity, that is technical word. In simple English it is identity. Identity means one student. Understood? One more student. So like that you will go on allocating memory now. Student S1, you will design this first, then you will allocate memory. S1 will have the values of student 1, student S2. Don't worry how you do it, you will allocate memory, store the values, all that we'll see now. So now it is very clearly designed. S1 will have the values of student 1, S2 will have the values of student 2, and you will access S1 dot student ID, S1 dot. So it's very simple now. So you are organizing your data more clearly now. This is brief introduction. Okay, theoretically I understood everything now, but we have to see it now how to do it in programs now. Practical is required now. So we'll start seeing the practical side of this now. Are you clear with all this? Okay, so two things we have to cover. And learning structure in C is very, very complicated. Okay, and to work with structure in C also it's very complicated. But in Java, working with your user-defined type is very simple also, very easy also. But to get adjusted to that syntax, it will take some time. 1 day, 2 days it will take. That's it. Okay, so what we'll do now with this introduction, what we can do is we'll see how to design our user-defined data types. I'll be going with the first data type. Which one is that? Class. Among the 4 data types, I'll be going that. And I'll give you the syntax of a class first. The syntax is very simple syntax. It is more complicated, but just I'll be giving you a very simple syntax. Generally, how a class looks. So this is how a syntax of a class looks. This is of the syntax of class data type. Okay, you'll be using a keyword called as class. To define the data type, you'll be using what? A keyword called as class. Then you can have an identifier. It's a name. For all data types, you have to give a name now. See, before you use a data type, it should be ready now. See, you are using int, float directly. Why? It is already ready, given to you by language. That's why we call them as predefined. Now these data types, student and all, are not ready. You have to prepare it and then you have to use it. So when you are preparing it, you will give a name, identifier. Okay. Then you will open the brace like this, and here you will have data type. This is the syntax. Variable name. You can have any number of variables. Variable name 1. Same way, data type. Variable name 2. Then you can have more. Then you can have return type. You know methods now? Return type, it can contain what? Variables and methods now. Okay, return type, identifier, or name I'll take simply directly. Name of the method, parameter list, then this will be the body. So in Java's data type, the concept is same, but it's more powerful. Okay, so we'll see how to do it. These are called as instance variables. So there's a difference between instance variables and local variables. Slowly you'll get the idea. It took nearly 4 or 5 days for us to understand what is a local variable. Similarly, it will require at least 2-3 days for you to understand instance variables. Then we can compare the difference between instance variables and local variables. But right now, in the class, any variable which is declared is called as instance variables. Just think that. Okay. Then these instance variables always contain what? They contain state, we say. Instance variables always contain what? State. Okay. And these in Java, you can write any methods like this, any number of methods. And this is technically in Java called as methods. And methods are containing what? They contain behavior. So this is one rough idea I'm giving you how a class looks. Methods contain behavior. Generally the methods will be using the value stored in the variables. And this concept is itself called as encapsulation. Understood? So the brilliant thing of Java is what you'll write your data type. After writing your data type, what happens? You'll compile it. Okay, this dot class will be ready now. We'll see how it is ready. Now this dot class file can be used in any operating system of the world. That is the brilliant feature of Java. You write your code once here, no? This data type can be used where? This class can be used in any operating system of the world, because you are not depending on any operating system here to execute any of the JVM. Okay, so why are you encapsulating now? What is the main reason for doing encapsulation, or what is the main advantage of doing OOPS? It gives you very high level of reusability and avoiding complexity. So once this is designed, anybody can use this anywhere. So finally it is leading to what now? Reusability and avoiding complexity. So the main advantage of OOPS is reusing and avoiding complexity. What are the 4 features are there? In OOPS, what are the different concepts? Encapsulation. We are still starting off with encapsulation, don't worry. Then comes abstraction. Then comes inheritance. You can study it in any order, but generally start off with encapsulation. Then last comes polymorphism. Just little idea I'm giving you about all this. Yesterday I gave you some definitions, but see, end of the day, whatever the definition, what it is, finally, what is the advantage of it, or why do you do encapsulation, or why do you do in abstraction, or why do you do inheritance? If you ask me, there are many questions which have to be answered here. What is encapsulation? How do you do encapsulation? When do you do encapsulation? Why do you do encapsulation? So these are the different questions we get. Same way, what is abstraction? How do you do abstraction? How do you do why do you do abstraction? Means bring all the interrogative questions. Interrogative means what? Question marks. Why, when, how, what? You bring that. You know the answer for only what is encapsulation, what is abstraction, what is inheritance. You are having only one answer. Okay, if anybody asks you why do you do abstraction or why do you do encapsulation, you don't have the answer. Okay, you rewind and play, you'll come back to the same answer. Encapsulation is so and so, encapsulation is so and so, you'll come back to the same point. Rewind and play, you'll come back there itself. Okay, but the main reason why you do encapsulation is very simple. It is for reusing and avoiding complexity. Let's see how we do all this now. This is just general syntax I'm talking. Same abstraction also is helping you to do what? Reusing and avoiding complexity. Same way. All the four are giving you support for the same two things. Reusing, avoiding complexity. It means advantage of doing inheritance is to reuse and avoid complexity. Advantage of abstraction is also reusing and avoiding complexity. Advantage of inheritance is also reusing, avoiding complexity only, nothing else. If you want, you write it fully. Reusing, avoiding complexity. So means OOPS is giving you four features for reusing, avoiding and avoiding complexity. But in one scenario you have to choose one. Okay, sometimes encapsulation will be good, sometimes inheritance will be good, sometimes polymorphism will be good. Okay, and to implement these four, Java is giving you again what? Java provides four data types to implement this. Again, you know now which one? Class, subclass, abstract class, as well as interface. So we have to study like this now. A big subject which will carry parallelly now. One side data types, other side OOPS. Understood? Just overview I am giving you. And this is the idea of a class now. So right now we'll be going with on the first one, encapsulation. And I gave you the idea also. Why do you do encapsulation? I want to write some logic. That logic I'll write it in a class. And this class can be used in any operating system of the world now. Understood? So we'll see now how to do it. Slowly we'll start getting the idea. So keeping this in mind, let's start studying what a class is, what is a user-defined data type also. Just keeping this in mind. But it will take minimum 8 to 10 days for us to understand what is a class. It's not like one day we'll finish it off. Okay, slowly you start understanding what a class data type is. So let us start off now. You got the syntax. So these variables contain state, and this is the same thing, I'm not deviating. Yesterday I wrote it. Encapsulation is nothing but what? Binding the data and the behavior together in a single unit. Binding the data and the behavior in a single unit. First I'll talk about data, slowly I'll add the methods, behavior. First I'll add the data, then I'll add the behavior. Are you clear? And see now, if you want to understand abstraction, encapsulation is mandatory. Abstraction is not possible without encapsulation. So until and unless we understand encapsulation, there is no question of understanding what? Abstraction. Clear? So first understand encapsulation. From there it starts off. Okay. Now I'll start designing our user-defined data type in Java. I'll start designing it. Initially, we'll not be focusing on encapsulation part of it. We'll be focusing on how to store the data. Are you clear? User-defined data type in Java. User-defined data type in Java can store data. Remember that. Plus, it can implement OOPS. You have to study two things now. Right now, I'm covering this part. Slowly, I'll end up into implementing OOPS. Are you clear? Yes, we know the syntax. Now, like the scenario is, now I want to work with one, let's take one entity now. Let's say it's a box. Like how we saw employee, student and all that now. Similarly, we'll take one entity now. That's called as what? Box. A box generally has what? Width, height and depth. See, right now I'm referring to all examples from complete reference, chapter 6. Okay, I'll take few examples from there, but most of the concepts it's through experience I'll be covering now. It's not like ditto to ditto we are going from what? Complete reference. You have seen complete reference earlier also. Okay, previous 5 chapters. There some topics are taken. Chapter wise I am moving like that, but concepts again we bring it from immense experience. From where? Other books also. Okay, so we bring it from other books also. So initially, okay, we'll start off from there itself. So now I want the entity is what I want to hold. Bagul, Bagul, open the door now. Okay, so the requirement is I want to hold the details of some box. Okay, so it will be like like it's an entity now, and the box has what? You know what is entity now? Student is an entity, employee is an entity. When they are entities, they'll have some set of values. Same I'm talking about box entity now. In box entity, what will you have? Width, height, and depth. 3 things will be there. So we'll start off with very simple things now. 3 values we'll take. Then we'll bring more values. And all these 3 values will be of type int now. I'll not mix. They'll be homogeneous only. Okay, they'll be homogeneous only. All 3 will be int only. Later on we'll start bringing what? 1 int, 1 float, 1 double, 1 string, that we'll start bringing. So our user defined data will look something like this now. See, class, and I have to give a name. Box is the identifier. Understood? Class, and this is the, you can give any name, but you know the convention now. I taught you rules for giving names. Rules, you know what is the rule? It should be alphanumeric, but first letter should be first should be a letter, not numeric. Okay, these are rules, conventions later, rules you follow, and I can use only dollar or underscore. Rules will remain. Okay, dollar underscore alphanumeric it can be. Okay, but first letter should be a alphabet. These are rules. Conventions now means we Java developers what we do. We never use digits here. We very rarely use digits. Even though it is alphanumeric, we don't use it while giving the name. Okay, and these are conventions. Convention means what? Some common standard what we follow for programming throughout the world. It's a common understanding now. I also have the common understanding. See, rules are different. Conventions are different. If you don't follow rules, what will happen? Compilation error will come. If you don't follow rules, it is against the syntax of the language, and you will get errors. If you don't follow rules, you will get errors. What errors? Generally, compilation rules. Now, convention means some best practices or standards followed worldwide. Worldwide, not I am telling this. Okay, worldwide, everybody, all Java developers follow these rules worldwide. Okay, so best practices are standards. Okay, rules are what? First rule. See all the rules you can note here. What are the rules? It should be alpha numeric. Should start with alphabet. Because it's an identifier. End of the day, it's an identifier. Okay. Which are the special symbols you can use here? Only 2 symbols. Dollar and underscore. Only 2. Not comma. I put comma and this one. Only 2 symbols. Okay. And there should be no space. These are all rules which will come. No space. So these are rules. And when you are giving a name of a class, if you don't follow this, you will start getting errors. Supposedly there is something like class cluster software. 2 words. Here I am using a single name. No space should be there. It should be attached. These are rules. Okay, it is mandatory. Now convention. Convention means what? The best practices followed worldwide. Okay. So best practices or standard means what? What are the best practices? We follow camel casing. Camel casing in the sense, first letter, first word, first letter should be caps. Second word, first letter should be caps. Understood? So you can have as big name you want, but first word, first letter caps. Second word, first letter caps. Third word, first letter caps. Like example, you can see, you already see in some built-in classes. See, even when some people also will give many classes. Built-in classes they are giving you. And you have worked with already built-in classes. One of the class name you have worked is string. It's a built-in class. And there S is caps now. See, they also write the code like this only. Class string. You have used one more class called as system. And the name of that is also what? So this is how they write. They are also telling us to follow the rule, and they are also following the rule. You should always practice what you preach now. Some is telling that and they are following it. And some more names are there. See, there is one class in Java by name string buffer. If you heard of it, I don't know. Computer science would have heard it, but others wouldn't have heard it. Anyway, we are going to learn all this. This all is there in the library. String buffer. So it's a class name, but it's having two words. First letter caps, first word first letter caps, second word first letter caps, like this. This is a convention, no space. Okay, so camel casing. You understood what's camel casing now? Okay, next. It should not have a digit. Not have a digit. Even though it's possible, we don't write it. And we do not have a special symbol also. So don't try using all this. Because suddenly say, if you have written a class, once you write a class, your class will be used by whom now? Me. I can use it. Okay. So now if you give the name like box underscore or something like this, string underscore buffer. Now how will I use a class name? You have to tell me very clearly. Use my class. The name of the class is string buffer. Okay. In between there is underscore. All that you have to tell. It becomes very difficult for us to use. You understand the difficulty. End of the day we are writing on Datatype to be used worldwide. Understood? But here if you don't follow the conventions, it's very difficult. Now supposing I use small s also, what will happen? If I ask you to use my class, you'll not know how to, means you'll ask me, okay, what is caps, what is small, confusion will start off. Okay, even I can give a name like this, STRINGBUFFER. How can others use this class now? They have to see every word and type now. So it becomes very difficult. So that's why we follow this best practices. Are you clear now why we follow the best practice? It will be easy for us to use. That's why before starting off only I am giving you all this idea. So you also, when you give a class name, you might have seen many times as giving the class name as following all these rules or following all this convention, not rule, convention. Okay, not have a special symbol, not have a digit. This is how you have to write it. Okay, so even though it can be cap, small and all that combination. Okay, you know how you write your name, and see, it's not complicated. If you are thinking it's very complicated, it's not as complicated at all. I give you a very simple idea to keep this in mind, a tip. Okay, how do you write your name? If I ask you to write your name, supposingly my name, how do I write it? First letter caps I'll write now. If I have one more name, middle name or last name or something, again, simple as that. Do I have digits here? There are special symbols here? No. Same rule. How you write your name, same way write it. Only just remove the space. That's it. You don't have to struggle to remember all that. Understood? You just don't have to struggle to remember all that. Even for methods, we follow camel casing. There also will not have digits, special symbol. Even though it's possible, we'll not do it. Sometimes in variables we'll use. That we'll see when. For variables we might use what? Digits and all that. But for definitely method name and class name we'll not be using special symbol and all that. And for method names, first letter will be small. First word, first letter small. Second word, first letter caps. Just one thing will change. The only thing what changes is first word, first letter will be small. That's it. Supposingly in class string buffer. Okay, let's take class string now. One of the method names here. One of the method name is equals. Starts with small. One more method is there with the name called as equals. Ignore case. Now see this method. E is small, I is caps, C is caps. So these are conventions. Understood now? Are you clear with the conventions? Only thing is first word, first letter will be small for a method. That's it. So even when you write notes, follow these rules. Else you will not understand your own notes tomorrow. That's why I am giving so much of stress to this. Tomorrow you will not be able to identify your own notes. What is method, what is class name? You will only get confused. If I say write string, if you write it in small, now what will you think now? Is it a class or a variable? Method? What will you identify now? String buffer, you will write it in small. What do you understand now? Tomorrow while reading the book. So even while following, writing the notes, follow Java conventions to write notes. Don't follow English standard. Use English. But when Java comes off, use Java conventions to write the notes now. Clear with all the identifier now? This is the story. Okay, so next. Yes, we'll come back. Little we'll deviate. Again we have to come back. Don't forget. The idea is how to design a user-defined data type. Lastly, what we have to reach is how to design a user-defined data type. Akkade open ಮಾಡಿ ikkade close ಮಾಡಿ. That side you open. This side you close. Okay, now see, we'll have the variables. Int w. Okay, so we are having now, what is a user defined data type? It is used for storing values. One width, it will have one height, one depth. Okay, let's see now. Int width, int height, int depth. 3 variables now. At the end of the day, these 3 should contain what? Values, no? So now in Java, these are called as instance variables. Just now I gave you the idea. And the instance variables and the methods put together, they are called as members. I didn't tell you that, you just write it there. You put on, both of them are called as what? Members of the class. Members of the class. Okay. Anyway, what are the members of the class? Instance variables and methods. They are called as members. I just forgot, when I wrote the syntax of the class now, syntax of the class, there you can write it as members. Okay, fine. Anyway, so these are called as what now? Instance variables. And they have to give a value. In Java, there are 4 ways you can give the values to the variables. In C, how many ways are there to give the value to your variable? Just compare. You'll come to know. In C, there is only one way. One you can hard code, or 2 is you can assign it with dot operator. You'll say no, student S1 is equal to new, something malloc you'll do, and then you'll fill the value S1 dot. So you'll use the dot operator. So same 2 things is supported in Java. Let's see extra what they give later. So you can fill the values into this. Okay, if you don't know C, forget it. If you don't know C, forget it. Not required. Okay, if you don't know how to work with the user defined data type in C, forget it. Not required. Directly learn how to use a user defined data type in Java itself. So what I'll do now, if I want, I can give the value. I'll give the value now 5, 6, 7. So these are variables now, and I have given the values. I have hard coded. Okay, so this is one of the way you can give values to your variables present in the user defined data type. Generally they'll come dynamically. We'll see how to get it dynamically, but we are hard coding right now. Yeah, and this thing what you are saying now is called as what? This entire thing is called as defining a class. This process is called as defining a class. You are defining it, or you are defining a user defined type. You are defining a user defined data type. First define it. If you want to use it, first define it. See till now, and here what we are defining is a class. Here what we are defining is, it's a class. Clear? So define it first. First you define it, then you can use. Like till now I was using int, float and all that. Why it was possible? Because they are predefined. They were predefined, but this is not predefined. We have to define it first, and then we have to use it. So it is defined. Next we can start using it. So I'll use this data type in my main method now, and almost all the syntax is same. Okay, see this. First I'll show you how to work with primitive variables. Int a. What is it now? Declaring a variable. Defining is done by language. This is declaring a variable. Yes or no? This is declaring a variable, but you are declaring which variable here? This is called as a primitive variable. Means a is a variable of type int. Okay, a is a variable of type int. That statement has immense meaning. You skip and proceed. That's why you fail to understand. See, technically all the statements start saying technically now. A is a data type of type int. A is a variable of data type int. That's how you have to understand. Similarly now you have got your user defined data type. Okay, I will write box B. What is it now? It's also one variable. B is a variable of type box. See here A is a variable of type int. Here B is a variable of type box. Understanding the difference now? Okay, A, B. If you are getting confused, I'll take a different name only. I'll take it as int Z. Z is a variable of type int. B is a variable of type box. Okay, but what is box now? It's a user defined data type. I have defined it. Okay, so here you are declaring a variable. But these are not called as primitive variables. These are called as reference variables in Java. A new terminology starts off now. Okay, declaring a reference variables. So primitive variables hold what value, you know? Primitive values. Primitive variables hold what value? Primitive values. What are the different primitive values? Decimal value, whole number value, boolean value. These are all primitive values. Okay, so these are primitive values. All this Java classifies it as primitive value. One more type of value is there called as reference value, address. But Java politely calls it as reference. Whereas in C they call it as address, a very complicated word. Okay, Java calls that address as reference, which is more polite, simple to understand. Okay, so let's see. So see here, again I'll repeat it. Z is a variable of type int. Here B is a variable of type box. And what is box now? User defined data type. So you are declaring it. You are only declared. Both the variables are not initialized. If you want, you can try to use it. Okay, see in C language, just I am telling you, if you want to work with your structure, what do you use? Pointer now? See, generally, let's summarize now. Forget Java. In all languages, how do you work with your user defined data type? First you define it, then you allocate memory. The address of that memory is stored in variable. Same subject now, same topic is coming up here, nothing different. Okay, you will define it. Okay, you will allocate memory. Still are not allocated memory. So when you are not allocated memory, where is the question of working with it? After allocating memory, that value will be stored in this variable now. Which variable? B variable. Same topic. But in Java it's more relaxed. No pointer, no headache. Okay, in C there is headache now. You have something called as pointer. C++ also headache is there. But in Java it is more relaxed. Let's see how comfortable you can work here now. B is a variable of type box. Okay, you try to work with both the variables. You will get the error. SOP Z, SOP B. Variable might not have been initialized. So without initializing, how will you work with it? Getting it now? Without initializing, how will you work with it? It gives you an error. Now how to initialize the variables now? There's a difference. Primitive variables are given primitive values. Reference variables should be given what? Reference values. That's the difference. Reference variables will be given reference values. Primitive variables have to be given primitive value. So you know what is a primitive value. You know how to work with Z. It's very simple. See here. Z is equal to 5. A primitive value was given to what? Z. Finished. It is given. Okay. But at the same time I have to give what? A reference value to box. See now when you are giving a value to a variable, you know the type of value should match. Yes or no? You remember this? When you are giving a value to a variable, the type of value should match. Okay. So B, for B you have to give the address or reference we say. Okay. But where is the address here? You can, in B can hold the address of only box address now. You are having this box now, it can hold the address of only box data type. It cannot hold the address of anything. It's very clear. In C there is a major drawback. Your pointer can hold the address of anything. But in Java I have told very clearly, B is a variable of type box and it should contain or hold address of only type box, nothing else. So clear it is. So when you look at a variable, it is very clear. This variable will hold an address of what? But in C you have a pointer. When you look at a pointer, do you know what address it will hold? It is impossible to guess. So when it is not possible to guess, how will you write the future code now? Understood? But in Java it's very clear. Okay, B means it is going to hold address of what? Only box. But where is the address of box? Still you are not allocated. So you have to allocate. So what we do? B is equal to, there is one keyword now. One more new keyword I am introducing now in the Java list. There are around 50 keywords in Java. And you know all the list of 50 keywords. So in that one keyword is there called as new. I am using that keyword. New box. In one language you use one style to allocate memory. In C++ you say new. In Java, sorry, in C you say malloc. Malloc, new. Concept is same, mechanism is same, but how you do methodology is different. Only Java has made it user friendly. So what happens now? So when you run this program, see you have compiled, okay. And one more thing, I forgot to tell you. Let's revise, go back now. So now there are two classes now. One is called as class box, one more is called as class demo. Two classes are there. You have to save the file. So what will be the name of your file now? So one Java file, one .java file, any name you have, demo.java. Okay, it can have any number of classes. When you are writing this is the source file. This source file can contain what? Any number of classes like this, class demo, class box. You can have more, class test, more you'll have. We'll go on writing it now. Okay, so we'll write now. So one Java file can have any number of classes. But generally when we save the file, okay, we save the file with the name of the class which contains main method. Generally when we save the file with the name of the class which contains main method. Now among this class box, class test, class demo, which class will contain main method? Generally demo. Any class can contain it, even a hello class can contain it, that's secondary. But that time your file name will be demo.java. You will compile now. How will you compile? You will always compile the file name java c demo.java. So once you compile, dot class will be generated. Now there will be 3 dot class files generated. So in your source file, how many classes are there? Those many dot class files will be created. Those many dot class files will be created. Means demo.class will be created, box.class will be created, at the same time test.class also will be created. And it is main method which goes on to use your user defined data types. Generally it's the class containing main method which goes on to use your user defined data types. It will start off now. So once these dot classes are ready, you will type now. What is the code you will write to execute? Java demo. So Java demo. See, these are all dot class files lying where now? In your hard disk. They are not physically existing. They are lying in the hard disk. I'll compile and show you now. All this will be where now? In your D drive, that month August, that folder they will be lying. Okay, it's still not running in the primary memory. So when I say Java demo, your JVM will start off. Now demo, when I say Java, Java command starts the JVM. Then demo.class loaded is loaded into the JVM. Okay, and in this class main method starts off execution. And when this line is reached now, what happens? New memory is allocated for box. So now box.class is loaded from the hard disk into the JVM. Now it will be loaded. So one by one, as we go on using, the classes will be loaded into the JVM. Means they physically come into existence. Till now they are not existing, but now they start physically coming into existence. And in Java, in this physical existence only we call it as object. This physical existence only we start calling it as object. So if you want to work with the class, generally we say we have to create objects. If you want to work with the class, we have to create objects. Understood? You have to allocate memory. If you are not understanding the terminology part of it, leave it. Just allocate memory. Once the memory is allocated in the JVM, this memory allocation in Java is called as object. Understood? I'll be showing you all this very clearly. Okay, very clearly you'll be see. This is theory wise. I still not coded. When I code perfectly, you'll start understanding one by one. Okay, so this will be, and the address of this, and here you'll have what? WHND. So how you have written your data type, same way the data type will come into existence. So this is new. New will bring the code into existence. So once it comes into existence, W will be 5, H will be 6, D is 7, and the address of this is given to B. Some hexadecimal address will be there. I'll show you. And that is given into B now. It will be like 150. Roughly I am writing. I don't know, it will be some hexadecimal address. I'll show it to you. So now in this, now memory has been allocated. This is an object now. Understood? So now once the memory is allocated, now you can work with that. Which one? Memory. But how will you work? Same like C. Use dot operator now. You want to access the value. Now see, there are 3 values. 5, 6, 7 are 3 values which are stored in WHND. If you want to work with that, you can use now SOP. You are accessing now. Don't think I am printing. The thing is how we are accessing the value. You notice that. Okay, how you access that value now? Value of W in box B is plus B dot W. See how I am accessing? I'm saying b dot w. Same way, it's almost all similar to C. There's no change. Almost all C syntax. You use what? Pointer variable or something like that and work. That's complicated, leave it. But here we are using what? Reference variable. Now this reference variable can store what value? Reference value. Same it is storing. It is storing the reference of what? Or address of box. But here no ampersand and all that. Like C. Here only what we do is new. Allocate the new memory and give it to B. Like this. So done. Next. Value of H in box B is plus B dot H. SOP. Value of D in box B is plus B dot D. Fine. You're printing now, what it prints? 5, 6, 7 it prints. As the program goes on executing, it will print. Okay, that's how we are accessing it. Are you clear? Now, if I want, I can calculate the volume also. Calculating volume is nothing but what? You have to multiply the value stored in W with H with D. Means whatever values are there, you have to multiply. But how do you access the value again? Using dot operator. Concentrate on that. Don't think I'm multiplying. You know how to do multiplication. But see how I'm accessing the value in that memory now. Okay, so we start calculating the volume like this. You can have one variable, int volume. Any variable name you declare, that's your wish. And I start writing is equal to b dot w into b dot h into p dot d. And now you understanding, see don't see about multiplication. Just see how we are accessing the value. B dot w, b dot h, b dot d. There's a value like 5, 6, 7. How I get that access? You start seeing that now. B dot w, b dot h, b dot d. Then multiplication happen. 5 into 6 into 7. 5 into 6 is 30. 30 into 7 is 210. That value is given to what now? Volume variable. And you can use that value now. Assignment operator now. Assignment operator, what it does? Assigns the value from the right hand side to the left hand side of the variable. And you can print now. SOP volume of box B is plus wall. Are you clear? So this is how it is getting executed. So first define it, then allocate memory, and once you allocate the memory, you store that address into one variable. Reason is why you are storing it, so that you can work with that variable. B dot W, B dot H, B dot D, you can work with that. Understood? It's a very simple process. And you can see the syntax is also very comfortable. It's not as complicated as C. In C, what happens if you want to design on user-defined data type, use it, it's very complicated. And minimum you take 2 to 3 months to reach to that level also. See, hardly in the third week, we are almost all reaching what? How to design what? User-defined data types here. Not that we have not got the grip, we are learning it. But at least we have the capacity to start learning it in the third week. Obviously in 3 months, you understand how strong you'll be in these data types. There you start learning, but here you start learning now itself. There third month you start learning. Here third week you start learning. Difference is that it's a very comfortable language. So that is the duration taken for learning one C language and Java language. So I'll code and show you this program now. Okay, I'll code and show you this program. Then you'll clearly understand this output. Clear? See, first what did I do? If I want to use it, I'll define it. Okay, first you have to define it. And this is collection of what? Primitive types. But here, even though they are all same type, okay, don't worry. Later on we'll have what? One int float double. First I want to design on user defined type. So it is having 3 types of values. 3 values. So we'll have it. Then it is encapsulated inside a class. Then what we do? We start declare the variable. To use it, first you declare it. Then you allocate memory. That address you store it in a variable. And once it is ready, you start using it with the dot operator. Very simple. Okay. Other side, more technical things are there. When you say, see, this is your Java file. This is your Java file. Okay. In your Java file, you can have any number of classes. So, but generally the name of the file will be what? The class which contains main method. It generally will be that. Even if you are interested, see, I can name my class name as what? This is valid. It is valid. You can compile also. But what are the dot class which generates? Demo.class, box.class, same dot class file be generated. So to compile you have to use this name now. To execute you have to use what?
Which contains main method.
So that's why to compile and execute we keep it as same name. What is the same name? The class name which contains the main method. Because it will be easy for you to execute. Otherwise, to compile you have to remember one name, to execute you have to remember another name. It's a convention what we follow. So once this is done, this dot class files will be generated. Next, when you say Java demo, what happens is, the JVM starts off execution. So all these dot class files which got created were lying where? Hard disk. They are not physically existing. So now what happens? Java demo, Java command starts the JVM, and now demo.class will be loaded, box.class will be loaded. Like that they'll come into memory. I'll be explaining you that process also. Okay, they'll be coming into memory. So then this box, when you say new, it will be allocated like this. Okay, then if you want, you can allocate one more memory now. See this, I'll continue the program. Box B1, you are again declaring what? A variable. Still memory has not been allocated for this. Understood? See, generally the first mistake of a computer science guy, what he does is, as soon as he sees this, he says it's an object. This is not an object. This is for your kind information. This is your first mistake. Your first line of programming mistakes comes where? In Java, computer science people create the mistake in the first line of the program. Understood? They create the mistake in the first line of the program itself. Where's the question of getting output later? Okay, computer science people especially. Okay, see this. This is only a variable. Still memory has not been allocated. How can you work with this variable now? Understood? When you can't work with the primitive variable here, where's the question of working with what? User defined variable. First, any variable declared should be initialized. So you initialize now. How you do? Same thing. B1 is equal to new box. Same. See, for reference variables, you have to give reference value only. Like in pointer, how you give only address, same way here also you have to give what? Reference value only. But they politely call it as reference. They don't call it as address. So one more new memory gets allocated. And in this also you are having WH and D. It will have the same values. Yes, this is the drawback now. This is the drawback of hard coding. We'll see how to get different values into your user defined data type now. So anyway, this is how it works. So this is B1 now. Address is what? 250. One more new memory. And if you want to see, there are totally 6 values. Totally there are 6 values. 567, 567. This 567 belongs to B. This 567 belongs to B1. You want to work with which 5? The one in B, then say B.W. You want to work with which 6? The one in B1, then you say B1.H. So which value you want? You access like that now. Understood? So there is one problem which remains now. What is the problem? Any number of objects you create, B2 also you create, that also will have the same value. We'll overcome this problem. But let's learn how to design the user defined data types. So there are 4 ways provided for you to initialize the values. So one of the problem in hard coding is what? Every objects will have the same value. That is one problem. Every objects now will have the same value. That's the problem. So later on we'll see how to give different values to this. Clear? So I'll just go ahead and show you this now. So once we go ahead and show you this.
Both those reference variables will be pointing to same box.
No, they are different. His question is, are they referring to the same address? They are not referring to the different address. Every time you go on saying new memory goes on getting allocated.
Already declared that B1 node and we passed B1. What will be the memory allocated for that? Because
First get output, then I'll tell you how much of memory is allocated. Understood now? So don't bother about memory. I told you how much of memory is allocated and all. One big class is pending. Okay, this is your main drawback in programming. What is the drawback in programming? You don't know how to write one simple line of code and you are worried about what? Memory. First write your code, get the output. How much of memory you require, I will provide. Understood? First get output. Clear this? Do not bother about memory. Hardly one line you will write how much of memory. That is really absurd. Understood? You focus on developing applications. After a complete application is ready, now ask how much of memory is required, we will supply. I know your question. How much of memory is what is that? Allocated for box B1. Understood? So if you want that information, yes, 8 bytes of memory is allocated. 8 bytes for all reference variables. 8 bytes of memory is allocated. But for primitive variables, you know the size. Now do you understand where it is allocated? Don't know, no. Then wait till I proceed to that level. What is my topic? User defined type, class, object. Focus on that. Why are you getting deviated towards memory? Subject is clear. Understood? You have to focus on the subject. It's a vast subject. Understood? So memory we will reach, and comfortably we'll be learning what is memory, where it is allocated, whether there is stack memory, heap memory. Now if I start teaching you that, what will happen? Neither will you learn this nor will you learn that. Now what you want to learn or not now? And then stick on to what? Very clearly I explained yesterday. Scope. You know what is scope? Within limits. So doubt should be within scope of the class, not that class, my class.
Sir, I think his question, the question was, as you declare the variable b1, what value it will be contained?
No, we are not discussing about that. I don't want any unwanted discussions. My topic is very simple, clear. My topic is how you design a user-defined data type, how you work with the user-defined data type. That's all my topic is. And yesterday night I didn't buy out your question. That is one more problem. If I had read it, I would have answered. Correct now? So, thing is, I'm just focusing on only one topic now. What is a user-defined type? How you work with that. When you are working with this much, just work this much. And obviously, further things will become very easy to you. Obviously, then we'll be dealing with memory. You start understanding the things one by one now. Understood? So, you focus on the subject of the class. I've got 2 hours of time here. In that 2 hours, I have to give so much of input to you. You start deviating, very difficult. Understood? And definitely we are going to learn that. We have covered so many topics, means obviously we are going to learn that also. It's not a problem. So fine. Any other questions within the scope? Yes?
Sir, can we change the values for that?
Yes, you can change the value which is hard coded there. How will you change the value? See this. And the value changed in one location will not affect the other one. See now. Anyway, I printed. What is the value it prints? 567. If I want, I can change the value. How will I change it? Where will I change? 1 second. Let me complete B1. So here also you print SOP. You can print your statement. Value of W and all that you print plus B1.W. Same way SOP. You print now. All the values. Value is B1.H. SOP. Value is plus B1.D. Print it. No issues. It will be 567, 567. But you are getting it from that location. If I change, see, I'll write the code here, just B.W is equal to 10, B.H is equal to 20, B.D is equal to 30. A very valid question. If I change it in B, yes, definitely it overrides. Because you are using the assignment operator, the value from the right hand side is picked, given to B. In B memory, it overwrites. Understood? You can change the value. And the value changed in this location is not affecting B1. B1 is still continuing to have the values of 567 itself. Understood? So you're working with memory like this. So B is referring to one memory, B1 is referring to another memory. Very clearly it shows, okay, you are working with 2 different objects. And this memory allocation itself is called as what? Object. This memory allocation. Okay, not this. When you say new, no, it allocates memory, no, that itself is called as a object. And it's a very simple now. Class is a user defined data type. See, all the definitions will come up now. Class is what? User defined. What is a class now? A class is a user defined data type. You know only this much. Again, you have to complete the statement. A class is a user defined data type in Java to implement OOPS. Now, that part we have not covered, but that is the actual definition of a class. So in the interview, if they ask what is a class, if you give that answer, what? A class is a user defined data type which is used for implementing OOPS. They are very happy. They are very happy. Anyway, OOPS is yet to start. Okay, but it's a user defined data type used to implement what? OOPS. That is first thing. Also, see, what is a class? It is a logical construct, we say. Means we construct it logically. Like how many variables? I'll clear all this 1 second. It is used for what? It means 3 variables, 4 variables, we construct it logically. Still it's going to continue, you'll understand. It is also called as a template. It is also called as blueprint. Anything you can say, no issue. Blueprint. Then next, is a defined logical blueprint. Anyway, you can say it is. Many words are there, anything you can say. But it is not physically existing. A class is not physically existing. You have to actually bring it into existence by allocating memory. Okay, and once you allocate memory, that itself is called as a object. But in other words, we also call it as instance. Instance and object mean same. Now let me still clearly want to explain you what is instance. Okay, the actual meaning of instance in English is example, single word. Okay, if you say what is the meaning of instance, it is called as example. It is example. Instance means example. If you want to clearly understand this, now understand the statement. I'll say means if I want to construct a building, I'll draw a plan. Why I'll draw a plan? So that constructing the building becomes easy. But once I draw a plan, it is existing on a piece of paper. It is not physically existing. It is not physically existing. So plan just lies on a piece of paper. But later on what I'll do? I will construct the building. Then I'll say building is an instance of the plan. So building is what exactly? Example of the plan. So when you have your templates, you have to bring them into existence. Remember that. Even in real world. Okay, even in real world, if you have a template, you have to bring them into existence. Now, same way, I have something like one more. You understood what is a plan and a building now? Same way, tree. Tree means what? Again, it's an idea. Like it's having branches, leaves and all that. Okay. Now again, if you want a tree, what do you have to do? You have to grow it. Okay. Means I'll take one mango tree, or mango seed or something. I'll start growing it, and now the tree comes out. Okay. So mango tree is an instance of what? Tree. Mango tree is an instance of a tree. Building is an instance of the plan. They are instances. Okay. And in the world, for one thing, there is one mechanism to bring them into existence. Remember that. End of the day, all are instances only. But for a tree, we grow. For a building, we construct. End of the day, what is happening? We have to allocate memory. We have to bring them into existence. Mechanism varies. Okay, I cannot grow a building. I cannot construct a tree. Remember that. Vice versa, you can't do. What approach is there for one product, that only you have to take. Same way here in Java also, for bringing things into existence, we use a keyword called as new. When you say new memory gets allocated. New memory gets allocated. Are you clear? So it comes into existence. So once it comes into existence, now see, mango tree is an instance of a tree. Understood? Building is an instance of the plan. Object is an instance of the class. Very clearly phrased now. Building is an instance of the plan. Object is an instance of the class. They are examples. So these examples do exist. They are physically existing now. Okay. And I told you, for one type of template, there is one mechanism to bring them into existence. Understood? In Java, what is the keyword we use? New. They are saying you new. They are giving you a keyword called as new. Understood now? You can't grow an object here. You can't construct an object here. You have to allocate memory. Means here we can say yes, that's the right word. You can construct an object. Okay. Means allocating memory only in Java is known as creating or constructing an object. It's same. But one methodology is there. Understood? Many things are there in the world. For one thing, there is one mechanism to bring them into existence. And once they come into existence, they are called as instances. So here also, when it comes into existence, this is called as an instance. The same thing is called as what? Instance. But in Java, we call it as object. It's the terminology. Okay, what is existing is called as instance. So this memory, what comes into existence, is called as what? Instance. So first create an instance. Now if I question you, simple. How do you create an instance of a building? I'll construct. How do you create an instance of a mango tree? I'll grow. How do you create an instance in Java? I'll use new keyword. Very simple. So once you use new, it will be created. And this is the instance. But Java technically calls it as object. And we get the statement now. What is it? Object is an instance of the class. So you can never work with the class. You can always work with object. So once a class is designed, there is no use of it. I'll design it. If I'm not using it, nothing, no use. You have to use it like this. Once a class is defined, okay, that is defining. This is declaring. Now what is this line? Creating an instance. See the three things here. That is defining a class. This is declaring a variable. This is creating an instance. 3 lines, 3 steps you have to take. 3 steps. First step is define it. Second step is declare a variable. Third step is create an instance. Are you clear this? Define means I have written in between some lines here. Forget that. Okay, directly you can say here what box B is equal to new box, also you can write in third line itself. Next line only you can write. Okay, so that's your wish. Are you clear with this? So initialize the variable and then use it. Initialize the variable and then use it. So this is the first mistake. Where is your first mistake starting off now? What is box P? Object. There itself gone. And you will try to print SOP_B.W. It is not working with any reference only. SOP_B.W, what will happen? Variable might not have been initialized, you will start getting error. And for that error you will tell what? You will start looking for semicolon. I show you now, that's a mistake. And you will start finding it difficult. Yes? It will address. This question is a good question. If I try to print SOP_B, what will it print? It will print the address. I will show you that also. Understood? It will print on hexadecimal address. Okay, I'll be showing you that. Are you clear with this program now? Shall I type this and show it to you now? Work with this. So this is where Java starts off. And working with the user-defined data type is very, very simple in Java. Did you notice? Define, declare, allocate memory, use. That's it over. It's not as complicated as what? See. Pointer, ginter story is not there at all. Clear? Shall I clear all this?
Can you declare one class in another class?
Can you declare one class in another class? They are called as inner classes, possible, and they form members of the class. Okay, right now I am teaching you how to declare variables. Then I will teach you how to define methods. Then I will show you how to write a class. One by one I have to go. I gave you a very simple syntax of a class. So this is a very powerful data type. You have to learn OOPS here. Very powerful data type. One by one. Understood? You have to go. Yes, any other question?
So, we have created a reference variable for box. Why we are not creating reference variable for the demo class? We have to bring that also in existence.
No, there is no necessity for bringing demo class into existence. We'll see how it works. The class containing main method, no need. We'll see when to bring that also into existence later. Okay, I'll start showing you now because see it's just starting off. All unwanted questions only you'll get. Silly questions because you are all becoming now Newton. First understand the basics, all answers you'll get now. So this is where you should get comfortable with the syntax now. This is where the Java syntax becomes very important now. Okay, so if you get this idea of programming now, bigger programs become easy in coding. Bigger programs will become very easy in coding because see right now we are designing a class. As I told you, later on what happens? Built-in classes are there. We'll work with built-in classes, libraries. Understood? So let's see now how to do it. So you can start coding in Edit Plus. So class demo, you can give any name. At the same, save the file. So always see this, you can have many classes now. So that's why what you do, box demo, you give the name. And you can give the new folder 1314 class data type. Box demo.java. Okay, then next. Sorry, closed it off. Okay, then next. Where did I say it? I said it correctly, no? Yeah. See now, first I'll remove this. How many classes there? Only one class. How do you compile? You can go to DOS prompt and compile. That's your wish. But I'll just show you the number of .class files D drive, edit plus example, August 13, Ravi Kumar, Java examples, core Java. Go to the location. Say I'll show you from DOS prompt also I'll show you. Okay, this is DOS prompt. Sorry. See, this is DOS prompt. I can compile from here now, or I can compile from where? Here also. Wherever you compile. See, if you say control 1 here, control and 1, Java C only is getting executed. So anyway, just see this. But when I compile it, one dot class file is generated. Java C box demo.java. One dot class file is generated. Valid? Okay. But in the same file, I'll write one more now. Class box. Again I'll compile. And no need of putting semicolon in Java at the end of the class. In C++ it's mandatory. But in Java, no need of putting semicolon in the end of the class. So now I'll compile. You can compile how? From here only control 1 you can do. But I still show you from there itself. Next we'll be doing from there only. I'll compile this. One now. See this Java C. Same file is compiled, but I get 2 dot class files. It overwrites. Box demo.class is overwritten. Understood? And box dot class gets created. One is overwritten, one new one is created. Next time I compile, both are overwritten. This is how it goes on. To execute now, what I should do? Java, you should use the class which contains the main method. So your file name can be different. So to compile you have to use what? Class name. Sorry, you have to compile you have to use file name. To execute you have to use the class name which contains the main method. To compile you have to use the file name. So best practice is what? Keep the file name and class name same. The class which contains the main method same. So that it will be easy for you to compile and execute. So your one file can start having more classes now. Clear? So anyway, this is done now. So you saw the output also now. Hello world. Okay. So we'll close off. We'll go back to our traditional style. Control 1 compiles, control 2 executes. Fine. This is an empty class. It's a valid code. So Java compiler is looking for the syntax of the class. Understood? And your class is not having any members. It is a valid class. It compiles, and in that dot class, no code is there. Understood? Okay. So in this dot class means there is no member here. If there is no member, there is no member here. So fine. So now you can start adding your member. See, I am defining my user defined type now. Int w is equal to 5. Int h is equal to 6. Int d is equal to 7. Again you can compile. Its syntax is correct. And now if your favorite error, if I don't put semicolon, yes, error. You understood when you get your semicolon errors. So here you are not terminating the statement. So you'll get the error. So anyway, this is how you are defining it. So what are you doing here? You are defining a class data type. Why are you defining it? To use it later, that's all. You are defining it. Fine. Next, what will you do? After defining it, you have to.
Sir, can you work with that predefined class box?
Where you want to work?
Sir, that box.
Where you want to work?
No, sir. Can we work with that box? I mean, the name is same as that predefined. That red color box.
Okay. His question is, this is showing red in color. So there is one built-in class by name box. Okay. Can I work? Yes, you can work. You can have two classes with the same name. But we deal with something called as packages. Right now preference is given to your class. Just concentrate on this. Okay. So you have defined it and it is creating. You are working with your class now. So WHND. Next. Class box. WHND. Next. See box. See first I'll show you how to work with primitive variables. Int z. Okay, and I'll try to print the value of z. Don't I get error here? Variable might not have been initialized. See how you work with the primitive. Focus on that. Variable might not have been initialized. You're getting the error. So what should I do now? I should initialize it. So this is how you work with primitives. Means you declare a variable, initialize. But what value should I give to this? Primitive value I should give. Because the type of value and variable should match. You know, when you are giving a value to a variable, the value and the variable should match. If it is matching, it will execute now. And compiler can detect it. Are you giving the correct value to the correct type of variable? Yes. Are you giving a whole number value to int data type? Yes. So it will compile. And it will work also. Now this time it works. 0 it will print. If you want to give 0, sorry, it's printing 0. Notice, if you want, you can give any other value. What? 5 also you give, it will work. That's your wish. But give a primitive value, but it should be of type whole number. Understood? So fine, next. So this is how you work with this. So let's, this is again what? Declaring a variable of type declaring a variable of type int. Then what? You are initializing the variable with primitive value. That is very important. Yes or no? You are initializing the variable with primitive value. That is very important. And that to what type of value? Whole number value. Done. Now let's see. Box B. So this is your mistake. What do you call this? You call it as what? Object. This is not an object. It's just you are declaring a variable, and this variable has the capacity to hold the address. Still memory has not been allocated what? For box. Okay. Memory is definitely allocated for this variable. That is one more thing. Memory is definitely allocated for this variable. Okay. Here also for int z, memory is allocated. Okay, how much of bytes? 4 bytes. Here also for reference variable, how much of memory is allocated? 8 bytes. 8 bytes of memory is, but memory is not allocated for box data type. For variable it is allocating. For the data type it is not allocating. Okay, so now you have to allocate the memory for the data type. Okay, so anyway, these points will become clear to you in the coming classes. Just hold back your doubts. Okay, so here what we are doing? Declaring a reference variable. You are declaring what type of a variable? A reference variable. Reference. Okay, means it can hold reference value. Reference variable of type box. That is very crucial. Now this can hold a reference or address of only box type. This can hold reference or address of only box type. In C language, if you want to work, you will go for pointers. If you want to work with your user defined data type, you go for pointers. Okay. So you will declare there now int pointer p. For that also, then you will give the address. Like that it is happening. Same way here, you will do this. Then what will you do? See now, new box. You are allocating memory now, or you are creating what? An instance. Allocating memory in Java is known as. See, for primitive types, no need to allocate memory. Understand that also. For user defined data types, it's mandatory to allocate memory. There's a huge difference between how you work with primitive type and user defined type. For primitive types, no need to allocate memory. Okay, Java is not pure object oriented language. Primitive types still exist in Java. It's not pure, but it is complete object oriented language. Means what? You have to write all the code in a class. Complete object oriented means you should write it in a class. Understood? No code is there outside the class. Notice, whereas in C++, your code can be outside the class. So that is syntax problem. So it's here very clear. Whatever you write, write it in a class. No confusion here. Because in C++ you'll have the question, when will write inside class, when will I write outside class? These are all silly questions which come out there. But in Java is complete object oriented language. Okay, but it is not pure object oriented language because of the existence of primitive types. For primitive types, no need to allocate memory, but for user defined types, you have to compulsory allocate memory. Yesterday I gave some notes to you. Refer to that. Literally you'll get the idea now. So the same points will build up now. Yesterday I gave it in short, but now we are going in depth into that subject. So once the memory is allocated, now what will happen? One second, before doing this, I'll try to print the value of B. This is what you do. See, your computer science people will do this mistake. Box B, and you'll say value of B is, or something you'll print, value of width is plus, this is your first mistake which comes out now, B dot W. I'll comment all this. I'll comment all these things. Now start seeing the problem. This is your first mistake in programming. You have defined it, you have declared it, but you are not allocated memory, and you'll try to compile, you get the error. The error is clearly shown here, variable might not have been initialized. But you are not looking for that error, you are looking for semicolon error. This is your mistake. Initialize the variable. How do you initialize it? You have to allocate memory now. How will you allocate memory? Yes or no? You have to allocate memory like this and give that to this variable. Yes or no? So what is this line now? See, this is step 1. This is step 2. This is step 1, define it. This is step 2. Third step is step 3. Create the instance. Done? Once it is created, next what you do? See, this is the same line. I'll comment here, but I'll paste it here. Definitely it works. Now memory has been allocated. Now see this. Control 1 compiles. Control 2. Value of width is, I'm accessing only one value. There are 3 values in box. In that object there are 3 values. Now what has exactly happened? Notice, box.class is present here. It is not actually in the memory. When you compile, your dot classes are lying where? Hard disk. Our dot class is nothing but a class. So classes are lying in the hard disk. Okay. From here, when you say, see, when the program goes on executing now, when you say B is equal to new box, now see, Java demo program starts off. So when your program starts off, see, this is Java demo. Demo.class will be loaded into the JVM. Next, main goes on executing. It will come to this line. One variable will be declared. I'll be clearly telling you later on how the memory is being designed here. There's something called a stack memory, heap memory, and all that we'll be seeing later. But exactly what happens when main goes on executing, one variable will be declared. Then one new memory will be allocated. Okay, the address of means now box.class is required. Now where is box.class? Where is box.class? Which location? See the location of the class. The URL you can see. Sorry, not the URL, the destination, where it is. Okay, you can see it is there. So now how will this dot class be loaded into the JVM now? You are having 160 GB or 280, means your hard disk size is so big. So Java command, what will it do? When you type Java command, Windows operating system will use path variable. When you type Java command, Windows operating system will use the path variable, identifies the exe file, and java.exe is found and it will execute. Java.exe will start the JVM. Demo.class is required now. Where is demo.class? Your location. And you know that now demo.class, the class has to be loaded now. Now JVM will use what? Class path. Operating system is using path to identify exe files. JVM is using class path to identify dot class files. Dot. So your dot class is loaded now. Which one? Demo.class. Then what will happen? Main goes on executing, and later on main needs which class? Box class. Now box.class is identified and loaded into the JVM. Now it physically comes into existence, and this physical existence is itself called as instance and better known as object in Java. It is now come into existence. From the hard disk it has got loaded into the primary memory. It has got loaded now, it's there. We can't see it, it's all virtual. Understood? Like building is an instance of the plan, you can see it. Okay, but here you can't see it, it is existing. And in this, see how you have designed your data type, same way the memory gets allocated. How you have designed your data type? You are defining your data type like this now, designing same. So same way memory will be allocated. So the dot class, means the class is loaded into the JVM like this and memory gets allocated. So until and unless this happens, in this line this is not happening. Only when you say new, this happens. So when this is not existing, how will you work with only B? Now only B is there, how will you work? Understood? You can't work. So allocate memory, that address you store it into a variable. Now work with this memory using b variable, b dot w. Okay, are you clear with this? And if you want, I'll print the address also. See the address. How will you print the address? You can print the value of b. I'll just print the value of b. I can print all these three values. First I'll print all the three values. Wait. Value of width, height, and what? Depth is what? B dot w, b dot h, b dot d. I'm printing all the three values. First let's see this. And yes, we are accessing all the three values. It is there in the memory and I'm accessing it with the dot operator. B dot w, b dot h, b dot d. I'm accessing all the three values. Can you notice this? I'm getting the value. Okay. So then next, supposing I want to print, I can print even what? Only b also I'll print. Value of b is b. Now see what it prints. It prints on hexadecimal address. Value first line output, you see value of box is what? Box at the rate of 19821F. It's a hexadecimal value. It's the address. So that address is itself stored in what? B. So when you say b dot w, that address dot w it will get. Understood now? B dot w means that address dot w it will be getting. But the same four statements, okay, what you do now? You print it here. Will it execute? B also is error. I'll comment all this. First line itself is error. B is not initialized. Yes or no? B dot w also error. So first allocate memory. Then you work with your user defined data type. Without allocating memory or without creating an instance, don't try to work with it. You'll get errors. So this is your mistakes here. Variable b might not have been initialized. In which line number? 20. Okay, I'll remove 20. Next, where I'll get error? Next line. B dot w. B is not initialized. B dot h is not initialized. B dot d is not initialized. You'll get errors all the way now. Clear? So do not work with the variable until and unless it is initialized. So one thing what is important is local variables, primitive variables will directly give the value. For reference variables, we have to allocate memory and give the value. So user defined data types are called as objects in Java. So there's a huge difference between user defined data type and primitive type now. And the topic is just started today. One day it is not possible to understand because you are not good in any language. Neither do you know what? C, C++, anything you don't know. So obviously in one language you have to struggle. Either you have to struggle in C or in C++ or in Java. Somewhere you have to struggle. And we are struggling to learn that in Java. It is better. Reason is you don't have to learn two languages and then come and learn the data type here. Directly you can learn the data type in Java itself. Unnecessarily you'll be wasting time there because to work in C now you have to learn pointer, which is a headache. Understood? Address, if you deal with address there on headache will come off now. Pointer will come off. So they are all headaches there. Understood? This is more simple. So once one box is ready, next what you can do? I'll use this code only now. What will I do? I'll make this as what? Okay, sorry. Okay, we'll bring it back like this. Is this code clear now? Next what will I do? If you want, you can allocate one more memory. See this. Box B1. Okay, B1 is equal to new box. Then value of B1 is, it will be a different address if you want to see this. Then value of width, height and depth is B1.w, B1.h. Which value you want, you get it from there now. Value of B1 is plus B1. Okay, similarly you can print value of width in B. Extra if you want to print. In B is. Same way. In B is. In B1 is. In B1 is. Done? See, compile this, execute, a neat output you'll get now. Very clearly it shows. Value of B is what now? 1982, then value of width is 567. B1 is what? You can see the address. Different now? It's totally different. So two memory has been allocated. So B is referring to one memory, B1 is referring to another memory. But here we do not call this as pointer. It is similar to pointer, but we use the word reference variable. It's a very polite word because pointer itself is a dreaded word. Understood? So Java people are trying to eliminate that word itself from the language. Okay, are you clear with this? And we'll see the drawbacks of pointer later. I'll not talk about the drawbacks. Why Java is not giving to pointers concept, we'll see it later. I'll not talk about that now. Clear? But Java has eliminated that. Fine. So then this is done. So now if you had one question, what if I change the value? Okay, first we'll calculate the volume. First I'll see how to use the 6 values. So what I'll do now, I'll calculate the volume now. I'll declare int volume 1 is equal to b dot, or int wall I'll take. Int wall is equal to, see how I'm getting the value? B dot w into b dot h into b dot d. See how I get the value, sorry. So use what operator you are using now? Arithmetic operator. B dot w into b dot h into b dot d. And then you can print volume of boxes volume of box B is plus what? Volume. Same way you can do it for what? Here what will it become? Volume 1 B1 dot volume, B1 dot H, B1 dot D. Volume of box B1 is plus volume 1. Understood? Simple. So control 1, control 2. But the value is same. There is no difference. First 192.586, volume of box B is what? 210. Same way volume of box B1 is what? 210 only. Because in both the objects value is same. Are you clear now? See, this is B and this is B1. Both will have the same value. And address of this is 150, address of this is 250. Simply I am writing 150, 250, but you know the address, it's a hexadecimal. Box at the rate of here, 19821F. Here the address is what? Box at the rate of ADD, it's a hexadecimal. Understood? Some value, don't bother about that. So you can work like this. So you want the value from which address? You start using now, B.W, B.H like that. Okay, now next let's change the value. You want me to change it where? After this I'll change. After all this, I'll change B.W is equal to 1. Simple values I'll give. B.H is equal to 2. B.D is equal to 3. Valid. Okay, after giving the values, now again I'll copy paste these values. Same thing. And you can see this time volume will be what? 6. So you are overwriting it in which object? Or B object. And meanwhile I'll comment B1 here. Okay, or I'll let B1 remain. If you modify values in B, it is not going to affect B1. Let it remain. And you can see this output. It's already defined. You have already defined the variable earlier. I can take volume 2. Just copy it and paste it. No, so that's why it gives error. Fine. Now see this. First it is B is printing what? To get the value for B 567. This output you can see. Volume is 210. Then you can see B1 values. What it is? 567. After that I modified. And now you can see address is same 19821F only. But the values are 1, 2, 3. Value of B is what? Same address. But in that address the values have been modified to 1, 2, 3. And if I try to use the value and calculate the volume also, it is 1 into 2 into 3. Okay, I have printed volume 1, means you print volume 2. Okay, that is it's printing this volume, this variable. So change the variable name to volume 2, which you have got now, it will be 6. Sorry for that. So it is printing 6. Are you clear with this? So this is how you define this one, and you allocate memory and you work with that object. Understood? Are you clear with this? Okay. So like this you can create more objects. But what is the drawback in this way? See, I showed you how to design a user-defined data type. I am not telling this is the accurate way of designing it. We are learning how to design it. Okay. So we learned how to design means you will have one class, in that you will have variables, and in that when the variables are there you will hard code the values. And if you hard code the values, what is the drawback? In every instance or object you create, what happens? Same values will be there, which is not correct. So in one object or in one instance or in one memory, I want one value, no, different values. In B it should be different, in B1 it should be different, in B2 it should be different, correct or not? That is also possible. So that is why in that case we should not hard code the values. You should not hard code the values. If you don't want that, you can do not hard code. So that's the next program. Do you have any questions with this program?
For instance variable default values are assigned or no?
That's the next topic I am taking. That's the next topic I am telling you. For instance variables default values are assigned or not, that's the next topic I am taking. Okay, hold back. I told you now. Because you start becoming Newton now. Einstein and Newton only. Okay, so the thing is now, we are not going to give what? Values to the instance variables. Because the problem if I give the value to the instance variable is what? Every object will have the same values. That is one problem now. Understood? So to avoid that, we can change the design of the class. See how you want your object to behave. You have to design your class in that way. So designing the class is so essential that finally your objects start behaving in the same way how you have designed your class. Your objects start behaving in the same way how you have designed your class. Because you have hard coded the values in your class, that is why the objects when it is getting created will have the value. That's the behavior. Understood? So that's why, see how you draw a plan, same way you will construct the building. There is no doubt about it. Correct? In the plan you will not have 2 bedrooms, and in building you will not have 5 bedrooms. Understood? What is there in the plan, same thing will come into existence. Understood? Same here. How you have written your class, same way it will come into existence. So let's see now. You understood the drawback of this? What is the drawback of this data type which I designed now? we worked, but in that data type there is a flaw. I'm not saying there is error. We are not getting errors with that. We are getting output, but there is a flaw. The main flaw of that is every time you create the instance, it will have the same value. Okay, to avoid that, let's see now how you change the design of your class. Understood? So I'll write now class box, same thing, but only difference is I'll not hard code the value. That's it. Same thing, but we are not hard coding. So I told you, for if you want to initialize values to your instance variables, see there are 4 ways to initialize your instance variables. There are 4 ways. Java gives you 4 ways. I don't know about C, C++. So Java is giving you 4 ways to initialize your instance variables. First one, second one, third one, fourth one. First one is hard coding. Second one is assigning a value using dot operator, bracket, dot operator. You use the dot operator and assign the value. Second one, third one is through methods, which we'll be seeing tomorrow. Fourth one is through constructor. So Java is very powerful. It gives you 4 mechanisms to initialize your values in the instance variable. Which is the best, last we'll decide. But we'll see all the possible options. Okay, if you learn like this, then you'll get the idea of how to design a class properly. If you learn like this, you'll understand how to design a class properly. Like this only you have to go. Step by step, then problem, then what is the next solution, problem, next solution, problem, next solution. Then you get the clear idea. Directly I can show you, this is the best way. Okay, but I'm not telling all the 4 are bad. Okay, in one situation, one will be helpful for you. In one situation, one will be helpful. All the 4 are correct, but extensively used one are these 2. You'll use methods as well as you'll use construct, extensively. Both you'll use. Okay, but I'm not telling again these two are bad. If that is bad, Java will not give you only. Some scenario they will also be helpful. So now I'm taking the second approach. First approach is gone now. So next we will be taking the second approach. Let's see now how you work. Class demo PSPM. So start declare your variable box B1. Okay, I'll declare it as B1 only. So your variables will generally be alphanumeric. Look at the name of the variable. They will be alphanumeric B1, B2, but not class name, method names and all that. So which one should be alphanumeric, which one should be not, we should be clear now. So it's only declaring. Has memory got allocated? No, I cannot work with that. This is just declaring a, what is this now? Declaring a reference variable. A reference variable. Still memory has not got allocated. How will you allocate now? B is equal to new box. So for the developer it looks like you are allocating memory, but in Java terminology this is called as creating an instance. In C you say malloc now, here is in C++ new, here you say new. Java follows C++ syntax here. So what happens? Shall I clear this? Okay, so here now memory is allocated. So this is B1. So how you have designed your class, same way memory gets allocated, and if you are not assigned the values to your instance variables, the default values of your instance variables will be, depends on the data type. If it is boolean, it would have been false. If it is char, it will be space. If it is float, 0.0. If it is double, 0.0. Okay, so it depends on your data type. So since it is of type int, the default values what it will be taking is 0, 0, 0. Because there's a big difference between local variable and instance variable. Local variables are not assigned with default values. Local variables are not assigned with default values. But instance variables are assigned with default values. Okay. So now see, if I declare a variable here, int z, this is called as local variable because this is there within a method. Okay. Local variables are existing where? Inside a method. So tomorrow we'll see the difference between local variable and instance. Today I'm not concentrating on that. Okay. So tomorrow I'll be concentrating on difference between local and instance. There you'll get the clarity. But for local variables, values are not initialized. But for instance variables, it will get the default value. Okay. So it will get the default value now. And if you are interested, you can print and see very clearly. It will show you SOP. Before initializing, you try it out. Value of W in box B is plus B dot W. It will print you what? 0. Similarly, SOP what? Value of H in box B is plus B dot H. SOP value of D in box B is plus B dot D. It will print you what? 0, 0, 0. So default values will be 0. Okay, if you are not hard coded. So this is how it will be there. If you want, you can initialize it. B dot W is equal to 1. B dot H is equal to 2. B dot D is equal to 3. Now in this memory, 3 values you are keeping. And here we are hard coding, no doubt. Later on we'll see how to bring dynamic values. So these values will come from the UI, as I told you, user interface or from database. So once you get that value, you'll put it off into one user defined data type. That's how actually it will be processed. So now see, processing writing logic is very easy. You don't bother about that. Learn to hold the values first. Without holding values, because so many values will be entering your application, without handling your values, without knowing how to handle the values, there is no question of writing any logic. And Java gives you a very elegant approach of handling values as compared to other languages. So it will be stored now. So it overrides. Same way how it was overwriting now. How 5, 6, 7 was overwritten to 1, 2, 3 now. I overwrite now. So same way 0 will be overwritten with what now? 1, 2, 3. After that you print SOP value of W in box B is plus B dot W. SOP value of H in box B is plus B dot H. SOP value of D in box B is plus B dot D. Here it was printing you 0, 0, 0, but here it prints you 1, 2, 3. Very clearly it will print. So it overwrites. And now if I want, I can calculate the volume. Int volume is equal to, see, just learn how you are working with the variables. You have to use the dot operator. Whenever you want to work with that, you have to use the dot operator. So dot operator is also a very big subject. Okay, very big subject. And remember, dot operator is used for accessing member of one class in another class. This is where it starts off. You will not get that point so easily now. There are some members here, WHND. The members of box I want to access where? In demo. So if I want to access it, I will be using the dot operator. That is, demo is one class, box is another class. If that demo class is interested to access the members of box class, so it will start using b dot. Understood? Variable dot. That's how it will be accessed. So dot operator is used for accessing members of one class in another class. Don't go into that now. Just I told you what is dot operator getting used. So I used it. Now see the same thing now. We are accessing the value. You concentrate on how you access the value. B dot h into B dot e. It's our subject. Understood? So SOP volume of box B is, I'm using B1 now. Okay, or I change the name B because everywhere I used B only. I'll change it off. B is plus volume. Finished. So what will it be? 6. Similarly, if you want to store 3 more values, they are coming dynamically now. So it will come from UI or it will come from database, somewhere it will come. But once the values enter your primary memory, again you have to put all these values into one more location. Okay, otherwise see, for storing 6 values, if I use 6 variables, A, B, C, D, E, F, G, what will happen now? Which value is belonging to whom you will not understand. But now it is very clear. 1 is belonging to B and it is there in B itself. 2 is belonging to B, it's there in B itself. Like that you are classifying it properly. So next 3 more values will come dynamically. So box B2 is equal to new box. So again one more new memory gets allocated, and in this memory you can print the address and see it will be a different address. So you'll have WHND and the values of this will be what? 0. Give values. Now these values will again come dynamically. I keep telling you now, they'll come dynamically either from user interface. So now see, store the values. B.W is equal to 5, B.H is equal to 6, B2.D is equal to 7. If you don't initialize, what are the default values? 0. If you want to print and see, after creating the object, you print and see, values will be 0, 0, 0 in B2 also. Put prints, maximum prints you will put, you will understand. Put maximum prints. Understood? So it will be 0. After that you initialize, then you print. What will be the value? 5, 6. Do the same process. What I have written there, same process you do for B2 also. It will be 5, 6, 7 now. Calculate volume, it will be 210. 3 more values will come. Now see, box B3. B3 is equal to new box. So as you go on getting the values, that time you go on allocating the memory. Again in B3, what will be the default values? 0, 0, 0. And now for B3 you give the values. B3.W is equal to 10. B3.H is equal to 20. B3.D is equal to 30. 10, 20, 30. So they will come dynamically. As you get the value, store it. Now totally you are holding 9 values. But 9 values are stored so beautifully in the primary memory now. Which value you want accurately you can get. You want 10, B3.W. You want 1, B1 dot or B.W. You want 5. Sorry, you are getting it now. Sorry, this name I changed. It is B. This is. Okay, one is B. This is B2. Yeah, B3. So if I want to see totally how many values are there? 9. Which value you want? Use the variable. You want 1, B.W. You want 3, B.D. You want this value 6, B2.H. How accurately you can access. Now logic you can write. Writing logic is not a big thing now. So 9 values, so comfortably you arranged it in the primary memory now. And all these values will come what? Dynamically. Do not bother now. Are you clear with this? So this is the advantage of designing a user-defined data type. Otherwise if I had used 9 variables, very difficult to handle and manipulate. 9. Later on there will become 300 values. What will you do now? Becomes very difficult. So 3 will put now. Like 100 box objects will create. And now you can work comfortably. confusion will not be there. But for 300 variables or values, now you have to increase what? English alphabets, because in English there are only 26 alphabets and you have to store 300 variables. Means what? You'll contact English language people and ask them to increase what? Alphabets, because you want to store so many values. Yes sir? That is not possible. So that's, I mean, just joking. Okay, means what happens that time you have to use variables name like A1, A2, A3, like that it will start. Once again 26 over, what will you do? A2, A3, I don't know how you will give name now, but storing 300 values is really a big task now. Okay, so like that what we start doing now, we start depending on user defined data types. So allocate memory, put the values, allocate memory, put the values, allocate memory, put the values. Whichever one you want, you can use it. As simple as this. But I have written B2 and B3. For B2 and B3 also follow the same steps. You'll clearly understand. When you create the object, values will be 0. Then you initialize like this. Like what is that? 5, 6, 7. Then you print. It will be 5, 6, 7. Then you calculate volume. So calculating volume was not my intention. My real intention is how do I access that value. If there is a value like 1 here, how do I get the value for processing? If means I am using that value for calculating volume. Volume is the logic you are writing. You are not finding difficulty in writing the logic for volume. You are actually finding difficulty in holding the values. Now if I had not used user defined data types and if I had used 9 variables A, B, C, D, E, F, G, H, I, J, K, and if I had asked you to calculate the volume, you would have multiplied with which one with which one? Whether you will multiply A with E or E with F, what will you multiply? It will be very difficult to keep track. But now it is very clear. I will multiply WHND of B. I will multiply WHND of B2. Like that it becomes very, very clear. Are you following now? So do you want me to type and show this? We can do it now. So this is the idea of designing a user defined data type. So here it starts off. Understood? Are you finding difficulty like C here? More comfortable now? In C also you are designing your user defined data type for storing values only. Here also you are doing it for that purpose only. But difference is, that is very difficult, this is very easy. Understood? Both are giving the same support. What is the difference? Support wise same. But it is rich also, at the same time user friendly also. It's very powerful. You have still not seen the power of it. Understood? So tomorrow I show you how to initialize the variables with methods. Then I will be showing you how to initialize with constructors. Approaches are there. Which one you want, you can take. Understood? Which approach you want to initialize, you can take anything. Clear this? Done? C++ also same story. There is no difference. Clear? No questions? Okay, that's it. No need to type and show, no? Okay. Thank you.